Welcome back. In our previous sessions, we performed several important measurements using half-wave and full-wave rectifier circuits. Today, we will learn how to model and simulate a 12 volts battery charger in MATLAB Simulink, using a full-wave bridge rectifier and a step-down transformer. Problem statement. Objective. Design and simulate a battery charger system in MATLAB Simulink, using a full-wave bridge rectifier and a transformer to step down the 220 volts RMS AC mains voltage. The system should safely and effectively charge a 12 volts, 50 ampere hours lead-acid battery. System requirements. AC supply parameters. Input voltage, 220 volts RMS. Frequency, 50 Hz. Transformer. Type, step down. Purpose, to match the required DC voltage after rectification and filtering. Rectifier type. Full-wave bridge rectifier using 4 diodes. Consider diode forward voltage drops, each of 0.7 volts. LC filter. Design and implement an LC filter to smooth the DC output. Battery specifications. Type, lead-acid. Nominal voltage, 12 volts. Capacity, 50 ampere hours. Charging current, between 10 and 20 amperes. Initial state of charge, 50%. Simulation requirements. Output voltage after filtering, around 14 volts, but not less than 13 volts. Charging current, between 10 and 20 amperes. Ripple voltage, peak to peak, must be less than or equal to 0.3 volts peak to peak. The simulation should run for at least 20 to 30 seconds to achieve steady-state response. Use scopes and measurement blocks to record. Output voltage. State of charge of the battery. Charging current. Getting started. Let's begin. First, launch Simulink by clicking the Simulink icon in the toolbar. Click on Blank Model to open a new blank model. Now, let us save the model. Click the Save icon. Give your model a suitable name. And then click Save. Add the required blocks. Let's add blocks to the model. Open the library browser. You can find the full course link in the video description. The simulation has completed. Now, let's check the results. You can see from the display that the state of charge of the battery has increased to 50.33%. Open the scope to view the graph. Now, check the current waveform. You can see that the charging current, once it reaches steady state, stays within the required range, that is, between 10 and 20 amperes. The voltage is also stable at the desired value. The peak-to-peak ripple voltage is far less than the required limit. You can also confirm this from the display. Summary. In this tutorial, you learned how to model and simulate a 12 volts battery charger in MATLAB Simulink, using a full-wave bridge rectifier and a step-down transformer. Your task. For the same model, increase the charging current to 60 amperes and build a control system that will connect or disconnect the AC mains supply based on the state of charge of the battery. Also, ensure that the battery does not discharge back through the charger when disconnected from the main supply. Hints. Use a breaker block from the Power Grid Elements section of Simscape Electrical. Connect the breaker in series with the AC voltage source. To control the breaker, monitor the SOC of the battery. Compare it with a constant value of 100, representing full charge. Use a relational operator block to check if SOC is less than 100. Connect the output to the control port of the breaker. To prevent battery discharge through the charger when the AC supply is disconnected, consider adding a diode between the charger and the battery. Thank you for joining us. You can find the full course link in the video description.